Now don't let all this empty space fool you. I like to leave a lot of space because some of my students have the big bubbly girl font, so it takes up a lot of space when they write. I'm saying guys have some of that same font too.
I was just gonna say, I'm
Yep.
looking at you like.
Oh no, big bubbly girl font. You know, they start writing like it really takes up a lot of space. So I want to make sure I had a lot of space for this. But let me show you how we're going to tackle coming up with the sine of a plus b. We're going to use our co-function identity. The sine of a plus b is the same thing as the cosine of 90 minus a plus b. Okay? And we're going to do a little sprinkle some algebra dust on this. We're going to think of this as being 90 minus a minus b. Distribute the negative through. And we're going to regroup this as 90 minus a, that quantity, minus b. So what I've just done, folks, is I've taken this sine of a sum and reworked it, so now I have it in terms of cosine of a difference. And we currently have, from the last section, right, we have a formula for cosine of a difference. I'm going to treat this whole expression as my angle A and angle B. And I'm going to plug those values or expressions into the earlier formula. Where's my undo? That's to get rid of the big A. So how do I find the cosine of a difference? Well, that is equal to cosine, technically A, but it's cosine 90 minus A, cosine B, plus sine 90 minus A, sine B. We okay so far? Anybody not understand where certain things are coming from? Go ahead.
I do. Since the cosine 90 minus A, why don't cosine B is like 90 minus A minus B?
Say that again? What?
See, this cosine 90 minus A, that's one angle.
I want you to think of this as one big angle.
Okay,
A.
that's A.
So here's A and
See,
B.
in order to get like angle B should be like 90 minus A.
Nope, because I just group those two together. So here's one angle, here's my second angle. Here's the first angle, second angle.
Okay, so B also always stays same then.
B's going to stay B. For now it is. Yeah. Now to clean this up, one last step, here at the bottom, what is the cosine of 90 minus A? Sine A. Cosine of 90 minus A is sine A. Cosine B. Sine of 90 minus A is cosine A sine B. And there's where they get the identity for the sine of A plus B. Now, how do you think we're going to end up getting sine of A minus B?
Same thing.
Same as before, meaning we're not going to use cofunctions. We're going to view, or we could view, sine of A minus B as sine of A plus negative B and plug those into this formula. Or you could go back and use cosines as well. All right. For the sake of time, I'm going to move on. You get the picture of how we can end up deriving all of these trig functions. Let's go to tangent. Let's take care of these two yet. Tangent of A plus B, tangent of A minus B are going to be very, very close to one another. But there is one part of this derivation that if I wouldn't have read it, I wouldn't have known to do it. And if I wouldn't have shown you what it is, you wouldn't have known to do it as well. But how do we prove things about or show things about tangent when all I have is sine and cosine information is converted, right? We know that the tangent of a plus b is the same thing as sine a plus b over cosine a plus b. So at the bottom, I need room to the right, so I'm going to write it underneath this. So we know that the bottom is cosine A cosine B minus sine A sine B. And the top is cosine A sine B plus cosine B sine A. There's where we're at. Now, here's where I mentioned earlier, had I not read this, I wouldn't have known to do it. And had I not shown you, you wouldn't have known to do this. But what happens next is we multiply top and bottom by 1 over cosine A cosine B. Multiply top and bottom by the same thing, which you know is a legal step. And we'll write what's left over. We're going to use distributive property on the top and the bottom. So imagine me taking, 1 plus cosine A cosine B times this first term. What happens? Cosine A's cancel each other out, and we have sine B over cosine B, right? Plus. Now we'll take that guy times the second term. Now my cosine B's cancel out, and I'm left with sine A over cosine A. So far, so good. What happens on the bottom? Well, we'll take same fraction times first term. Cosine B's cancel each other out. We're left with cosine A over cosine A. That's just 1. Minus one more multiplication step. When we multiply these two together, what do we get?
1.
No. Looks like we're going to get sine A sine B over cosine A cosine B.
Ain't that?
Sine A over cosine A times, well, I'm making it sound more difficult than it is. It's going to be negative sine A sine B on top. And on the bottom, we're going to have cosine A cosine B. All right. Now we can clean this up a little bit more, make it look a little bit more friendly. Up top, the numerator, what's sine B over cosine B? Tangent B. Plus sine of A over cosine A is tangent A. So on the bottom, 1 minus, what are we left with? Tangent A, tangent B. Tangent A times tangent B, if you separate it that way. Tan A, tan B. And I'm going to cross my fingers and ask, is that the identity for the tangent of A plus B? So you look at the cover of your book and say, oh, there it is. Now I know where they get it from. Right? For the sake of time, like I said, we derive tangent of A plus B. For tangent of A minus B, all you got to do is think of it as being the tangent of A plus negative b, and plug those two angles into the one we just derived, and that would lead to the identity that you're seeing. Okay? So those are the four we just derived. We have the two that we learned in a previous section, cosine of a sum, cosine of a difference. Here are your sine of sum and difference, and here are tangent of sum and difference. Not going to make you memorize these for an exam. However, I will warn you, your calculus person, if you choose to take calculus here or somewhere else, may require that you have these memorized. Now you're going to start seeing a lot of the same type of problems as we just did. Okay, let's start with letter A. Let's come up with the sine of 75, exact value again. Well, I don't know, or there's no expression for the sine of 75. So let's break it up into two special angles that I do know how to find the sine of. 60 plus 15. What did he just say? Let's try another combination. 30 plus 45. Because I don't know 15. I will know 15 in about a week, because we do half angle identities. So there's a relationship between the sine of 30 and the sine of 15, but we'll learn that one later on. So now I run up to my my sine of a sum formula. That will be sine, actually it doesn't really matter which one you start with. I guess I'll stay uniform. Cosine 30 sine 45 plus cosine 45 sine 30. I mean, I have most of these kind of memorized, but there's times I'll just write the wrong thing down. You guys will catch me because you have your book open to the page. Is this right? Sine of a sum, sine of a plus b. Looks right. Cosine of 30, square root of 3 over 2. Sine of 45, square root of 2 over 2. Plus cosine of 45, square root of 2 over 2. Sine of 30, 1/2. Root 6 over 4 plus root 2 over 4. Answer, root 6 plus root 2 over 4. And I think last time we came up with that, that sign was a minus for the cosine answer. So there is the exact form for the sine of 75. You ask your calculator to 4 decimal places, what's the sine of 75, versus asking calculator to simplify that expression right to 4 decimal places, you'll get the same thing. This is the exact form. Okay? And the rest I'm going to keep on going. You can make the connection between what we did earlier and what we're going to do now. You're just going to use a different trig identity. All right. Do you remember me saying earlier you had the 2 different pictures, one for angle S, one for angle T? I want you to do the same thing. I'm going to let you go and start on this problem. You got 2 angles again, angle A and angle B. You're told some information about the 2 angles individually. Come up with some of the other missing pieces so that you can answer those 3 questions. I'll give you some time and then we'll go over it and then we're finished. Other than I want to do a tangent example too. Maybe this helps. A couple of things that I want to point out is I'm glad you saw that this is code for, hey, angle A is in quadrant 2, and this is code for angle B is in quadrant 3. So draw your diagrams accordingly. Angle A, quadrant 2, you get a 3, 4, 5 triangle. Angle B is in quadrant 3. So you get a -5, -12, 13 right triangle. So for letter A, what's the sine of A plus B? So you see that's cosine A, cosine B, cosine A sine B plus cosine B sine A. Fill in those values with your two pictures over in the left-hand side. And where I made the mistake was I forgot this negative. That's to be implied a -3 because you're going to the left. So we get a positive 36/65 plus -20/65, ending up giving us 16/65. So there's the sine of A plus B. Questions there? For the tangent of A plus B, we'll use the tangent of a sum identity, tan A plus tan B over 1 minus tan A tan B. So tangent A is 4/3, tangent B 12/5. On the bottom we have 1 minus 4/3 times 12/5. I just dumped everything into the calculator and said, give me a fractional answer, and we get -56/33. Right? Now comes part C. What quadrant?
I still don't get that negative
Hang on.
56.
What?
Did you miss the negative for the 3 again in part B?
Part B. Here, which angle?
Tan A.
Tan A. Tan A. Tan A. Y over X would be 5, -5/3. No.
How'd you get 33 in the bottom? That's what I don't understand.
Y over X. Be -4/3. Yeah, that's going to change everything. So that should be -4/3, and that should be -4/3. So let me redo that on my calculator quick. It's probably the lowest terms denominator. That's why it's throwing you off. So let me undo, go back, and let's make that a -4/3. And let's go down here and make this one a -4/3. And let's convert that to a fraction. 16/63. Positive 16/63. That's what you get. If you want to know how we do that in the calculator, we'll do that when I'm done up here. But you're looking at that.
That's what I have, but negative.
Should be positive.
Well, I know that's because I did it wrong.
Okay. Should be positive. And whether or not these answers for A and B are positive and negative, it's kind of a big deal, because if you get those wrong, you're going to get C wrong. The question for C would like to know, what quadrant is this angle A plus B in? So what we have
Wouldn't it be -16/63 though? Like I still.
is I have to go back up here and say, okay, let's take a look at the sine of that angle and the tangent of that angle. A told us sine is positive, right? So what two quadrants is sine positive? 1 and 2, right? Down here we also found out that the tangent of the same angle, positive. Where is tangent positive? 1 and 3. Where's the overlap? 1. So this angle has to be in quadrant 1. Okay.